Good evening, children. Today I will explain about measurement of gas pressure and gas loss. Introduction part is completed. Okay, see all of you. This is one manometer. This is one manometer. What type of manometer is it? Open end manometer. Open end manometer. Open end means one side is, see, listen all of you carefully. This is one liquid. This is one liquid. One liquid is present in the manometer. One side, this is pressure created by the gas, outside gas. Pressure created by the outside gas because this side open. But another side, one gas is filled. One gas is filled. Any gas, hydrogen, helium, nitrogen, any gas is filled and closed this side. So this gas creates some pressure on this liquid. This gas creates some pressure on this liquid. And another side, normal gas means that is air creates some pressure on this side. If these two limbs are, these two surfaces are equal like this, in this case, P gas means pressure of the gas is equal to pressure of the atmospheric gas. Pressure of the atmospheric gas. This is first formula. So in first formula, what is that one condition? Both sides that limbs are in the same level. Come to the second case. In this case, the P gas is very high. Due to that gas pressure is very high, these limbs are not equal, and this liquid actually starting initially same surfaces. But if the pressure of the gas is very high, comparing with the pressure of the atmospheric gas, so this one move to down and this one move to up. Now observe this one. Now we observe this one. So the pressure of the gas, in this case, pressure of the gas is greater than pressure of the atmospheric gas. Then what is the suitable formula for this one, sir? Listen all of you carefully. So this one, this is extra distance. Actually, we expected these two are equal surfaces, but this extra part is called pH. This extra part is called pH. pH means difference between two lobes. Difference between these two lobes. Okay, Nana? So P, pressure created by the gas is greater than the pressure created by the atmospheric gas in this condition. So here, this is greater than this one. So how to equal to pressure of the gas means on another formula. P gas is equal to P atmosphere plus here pressure created by the, so distance between the two lobes. Distance between the two lobes. Okay, it is, I think, very easy it is. Now the reverse case. Third one is reverse case. What is the reverse case here? The pressure created by the atmospheric gas is greater than the pressure created by the gas. So in this case, P gas is less than P atmospheric gas. So I think we expect an easy equation here, that is third one. P gas plus this difference pH is equal to P atmospheric gas. So these three formulas for open end manometer. Open end manometer. Right? Next case, closed end manometer. Second one, closed end manometer. Closed end manometer means both sides are closed. We know that this is one end, this is one end. Both sides, this side also closed. We know that I have told to you. This is gas, one gas is filled here. One gas is filled here. Okay, and these are the lobes of the liquid. This is pressure of the atmosphere gas. Okay, but there is no atmospheric gas. There is no atmospheric gas because this side is closed. Then in this case, P gas is equal to this distance, pH. pH. So pressure of the gas is equal to the distance between the two lobes. Distance between the two lobes or height of the lobe. Okay, this is about closed end manometer. Next one, gas laws. Gas laws, very important. Gas laws. First gas law, Boyle's law. Boyle's law. Okay, Nana? Boyle's law. Sir, what is Boyle's law, sir? Remember, actually, 4 laws are present. First one, Boyle's law. Second one, Charles' law 1. Third one, Charles' law 2. Fourth one, Avogadro's law. Okay, sir. So, in this case, in this gas laws, we are learn about the relations between temperature, pressure, volume, and number of molecules or number of particles. Relation between these 4: temperature, pressure, volume, and M means number of moles or number of particles. Sir, Boyle's law. What is Boyle's law, sir? At constant temperature. Remember, at constant temperature, what is the relation between volume and pressure? This is the relation between volume and pressure. At constant temperature, volume of given mass of a gas is inversely proportional to the pressure of the gas. This is the definition of Boyle's law. I will repeat again. At constant temperature, volume of given mass of a gas is inversely proportional to the pressure of the gas. Very simple. If pressure is increases, volume is decreases. For example, here up to this one, gas is filled. Okay, gas is filled up to this one. So this surface is, if for example, if we take as a piston, that one is, if apply some pressure on the piston. Now this gas molecules have comes very close. It indicates if pressure is increases, volume is decreases. If pressure is increases, volume is decreases. Means pressure and volume, these two are inversely proportional to each other. That is the Boyle's law. But condition is we have to maintain constant temperature, because if temperature is increases, volume is also increases. Then the pressure condition is not applied perfectly. That's why for Boyle's law, we have to maintain constant temperature. At constant temperature, volume of the given mass of a gas is inversely proportional to the pressure. Or in other words, volume of the given mass of a gas is directly proportional to the 1 by P. No problem, both are same. Now for removing this proportionality, introduce one constant, that is proportionality constant, K into 1 by P. If P move to this side, PV is equal to K. So PV is equal to K means PV equal to constant. Okay, right. For any two gases, the relation is P1 V1 equal to P2 V2. P1 V1 equal to P2 V2. I think it is very clear. It is very clear. P1 V1 equal to P2 V2. Right? So of course this can be right, or in other words, P1 by P2 is equal to V2 by V1. Both are same, no problem. We can convert in any manner, no problem. Okay, sir. Now graphs about this one. Sir, remember all of you, This is the important one relation. This is the other important relation. These two are important. Now graphs. How to draw the graphs? Right. So first, volume and pressure. Volume. What is the relation between volume and pressure? If you draw a graph between volume and pressure, what is the relation? If pressure is increases, volume is decreases. For example, initially started here. So in this case, this is the pressure. If pressure is increases, initially volume is very high, but with increasing the pressure, volume is decreases. Volume is decreases. What is this one? Hyperbola. What is this one? Hyperbola. We observed here. Okay. This is the first graph. Now second graph. Second graph. Second graph. Volume and 1 by P. These two are volume and 1 by P. These two are directly proportional to each other. Directly proportional to each other means if volume is increases, 1 by P is also increases. If 1 by P increases, volume also increases. So both are directly proportional means this is the graph. Now third one. Third one. Relation between PV and P. Sir, actually PV is always constant, sir. There is no change. There is no change, sir. So it indicates if you change the pressure value or volume value anything, the total, the multiple PV value is always constant. There is no change. So this indicates no change. If pressure is changed, but no change in the PV value. These three graphs were at constant temperature. Sir, what if you change the temperature? What you are observed, sir? Okay, these graphs also I will explain now. In case if temperature is changed, we observe different hyperbolas. Okay, this is T1, this is T2, this is T3. Right? Means temperature is increases, the hyperbola positions also changed. But we observe only hyperbola because volume and pressure are always inversely proportional to each other. But remember, this temperature, this is low, high and high. So it indicates if temperature is increases, volume also increases. That's why volume graph, this graph is up. Sometimes for a graph's identification, T1, T2, T3 is given, it is wrong. It is wrong. Remember this one. Okay, right. In second case, this one, volume and 1 by P. This type of graphs we observe. 1, 2, 3. Means these three coming towards this position only. This position only. But at three different temperatures. So which is highest, sir? So this is the highest we observed. So this is T1, T2, T3 because for temperature zones, one see here volume. So here volume is increases. So for different temperatures, different volumes. Okay. Now third one. This is third one. PV and P. Here also we observe different constant values. T1, T2 and T3. T1, T2 and T3. These are the graphs. Okay, Nana? Now, another interesting relations in this concept. Actually, PV is equal to K. We know that. PV is equal to constant. Now take both sides logarithm. Logarithms means log PV is equal to log K. Log K means, okay, K is constant here. K is constant. But log PV, you know that logarithms formulas? Log AB equal to log A plus log B. This is the formula. By using that formula, log PV means log P plus log V is equal to log K. This log V move to that side. Log P is equal to minus log V plus log K. Of course, log K is constant. This is always constant value. Because k is constant, logarithm k value is also constant value. Right. So what about minus log v, sir? Remember all of you, log 1 by a is equal to, if a come to the numerator position, log a power minus 1. This one move to this place, minus log a. Minus log a. Okay, Nana? Right. Similarly, this minus log v means, minus log v means this one move to this place, v power minus 1. So simply it is written as log 1 by v plus log k, log p. So log p is equal to log 1 by v plus log k. This is looks like y is equal to mx plus c. What is the formula? Mathematical formulas. Y is equal to mx plus c. What is the graph we expected here? For this one, now this is one graph, this is one, this is two. Okay, this is looks like, this is first one, this is looks like y is equal to minus mx plus c. Minus mx plus c. This is looks like y is equal to mx plus c plus m minus m. For this one, first I will draw the graph. Here on y-axis log p, on y-axis log p, on x-axis log 1 by v. Okay, what type of graph you expected? This is the graph. This is the graph. Okay, in this case, slope m is slope. There is no value means slope value is 1, and intercept c, that is log k. Intercept is equal to log k value. But for minus log v, we observe different graph, that is log and log v. This is different. This type of graph is observed because minus value. So graph is reverse. Graph is reverse. Okay, Nana? So here slope is minus 1 because minus log v means minus 1, right? Intercept is log k. Intercept equal to log k. Are you understand? Right. And one more relation for this one, density relation. Density is equal to d. Density d is equal to mass by volume. So d is equal to m by v. D equal to m by v. Okay. So here, what is the relation between here? Density is inversely proportional to 1 by v. We know that pressure is inversely proportional to v. We know that v is inversely proportional to p. These two are same. Okay. Right. So from these two, these two are d is inversely proportional to v, p is inversely proportional to v means these two are directly proportional to each other. These two are directly proportional to each other. Okay. So for this one, if you draw a graph between density and pressure, directly proportional means this is the graph between density and pressure. So for removing the constant, d is equal to kp. This is k is proportionally constant. When p move to this place, d by p is equal to k. So when you draw a graph between d by p and p, it is always constant. Okay, one more relation from this one. For any two gases, d1 by p1 is equal to d2 by p2. For any two gases, this is about total explanation of Boyle's law. Second one, Charles' law. What is Charles' law? Very important and very interesting. This is at constant pressure, the volume of a given mass of a gas is directly proportional to the temperature. I already told you. If temperature is increases, volume also increases. Okay. For removing proportionality, we introduce proportionality constant K. So V is equal to KT. So if KT is moved to this side, V by T is equal to K. That is constant. That is constant. Okay. For any two gases, V1 by T1 equal to V2 by T2. Okay, this one most important. Right? Now graphs for this one. Volume and temperature. These two are directly proportional. This is the graph. Volume and temperature. Now V by T is equal to constant. So we expected the graph. For example, V and 1 by T. This is reverse graph. Because this is V and volume and temperature. This is volume and inverse temperature. That's why this is the graph. Okay, for V by T and V, either V or T, no problem, both are same. Either V or T, this is always maintains constant graph. Okay, now I already told you V is equal to KT, taking both side logarithms. So log V is equal to log KT. So log KT means log A plus log B. So log V is equal to log K plus log T. Log K plus log T. Okay, sir. Now this looks like Y is equal to, this is Mx plus this is C. Now draw a graph between Y means log V. Here X means log T. This is the graph. For log V and log P. Y is equal to Mx plus C graph. What is, you know that? Y is equal to Mx graph. This is Y is equal to Mx graph. Y is equal to Mx graph means this is the Y is equal to Mx graph. But Y is equal to Mx plus C means this is the Y is equal to Mx plus C graph. Minus Mx is this is the graph. Remember, these are all mathematical equations, mathematical graphs. Okay, sir? Completed? Experimental verification for Charles law. Remember, all of you, it is very important and very interesting. Experimental verification means if you take any gas, okay, for example, at 0 degrees centigrade, volume of gas is V0. So for example, if we take one gas at 0 degrees centigrade, its volume is V0. Okay, at T degrees centigrade means, for example, if you increase some, for example, 10 degrees centigrade, how that volume of the gas is Vt. Sir, how much fraction is increases, sir? Or how much fraction is decreases, sir? Remember this one. For each degree, volume change is 1 by 273 fraction. 1 by 273 fraction is changed. Remember all of you this one. For each degree, 1 by 273 fraction is changed in any volume. So for calculating the Vt is equal to initially V naught plus how much is changed here? V naught by 273 into T. Here T means how much temperature is raised. So V naught is initial. How much fraction is increased? That is 273. That is 273. So for example, we expect for example initially 273 ml volume is present at 0 degree centigrade. So at 10 degrees centigrade we expected 283 ml. So the 10 ml how to change? The 10 ml how to change means that is depending upon the change in the temperature. If temperature is increases, volume also increases. If temperature is decreases, volume also decreases. So how much part volume is changed means that part is 1 by 273 fraction. So simple formula, so that Vt means at T degree centigrade volume is calculated that initial plus initial by 273 fraction into how much temperature is changed, that is T. Okay sir, so take Vt is equal to V naught is the common V naught 1 plus T by 273. 1 plus T by 273. This is equals to V naught into 273 LCM 273 plus T. Okay, right. Okay now. So this scale, this 273 fraction changing is there now. This scale is called Kelvin scale or absolute scale. So a new scale is introduced. A new scale is called Kelvin scale or absolute scale. Absolute scale. Okay, right. So what is the absolute zero temperature means? That is absolute zero temperature means minus 273 degree centigrade. So absolute zero temperature means at 273 degree centigrade the particles are never move. The particles are never move. Remember this point, all of you. Okay na? So this is experimental verification, right? Completed na? Charles law completed. Next one, similar one, that is Charles law 2 or Gay-Lussac law. Charles law 2 or Gay-Lussac law. But this absolute scale is given. One more graph. This is lesson. See all of you carefully. This is temperature. This is volume. This one is minus 273 degree centigrade. This is 0 degree centigrade. This is the graph. Because if temperature increases, volume also increases. But start from minus 273 degree centigrade. Start from minus 273 degree centigrade. This one also write like this. Volume, temperature. This is the taken as minus 273 degree centigrade. This is also same graph. Both are same graphs. Okay. Sir, if actually these two conditions for the constant pressure. If pressure is changed, what is the graph? What is the graph? So this is P1, P2, P3, P4. These are the different pressures, volume and temperature changes. Okay. This one, Gay-Lussac's law or Charles law 2, third one. At constant volume, pressure is directly proportional to temperature. It is very interesting. Sir, if temperature increases, pressure is decreases, we expected. But this is only for gases. Yes, Gay-Lussac's law. At constant volume, pressure of the given gas is directly proportional to the temperature. Sir, In this case, in most of the cases we expected, if temperature is increases, pressure is decreases. But here, listen carefully. The gas is present in the closed container because this is only for gases. Only for gases. Already gas present in the container. If the temperature is increases, then the gas particles are moved to outside. Try to move to outside. At the time they create more pressure on the container, more pressure on the walls of the container. Means they push. That water particles are push means create more pressure on the walls of the container. So if temperature is increases, the pressure created by the gases particles are also increases. This is simply written like this: at constant volume, pressure is directly proportional to the temperature. Now remaining part is very easy. For removing this proportionality, P is equal to KT. So P by T is equal to K. So for two gases, what is the formula? P1 by T1 is equal to P2 by T2. Now graphs for this one, very simple graphs. For pressure and temperature, both are directly proportional. So this is the graph. For pressure and 1 by T means reverse temperature. Actually both are directly proportional. For 1 by T, this is the reverse graph. For pressure, P by T and P by T and P or T, no problem, both are same. P by T is constant means there is no change. Are you understand? Next one. Sir, similar type of Charles law one. P is equal to KT. Apply logarithms both sides. Log P is equal to log KT. Log KT means log A plus log B formula. So log P is equal to log K plus log T. But this is constant value, so taken as a C. So this is equal to Y. This is mx. See, y is equal to mx plus c. C means constant value. Now draw a graph for this one. Log P and log P. This type of graph is coming. Okay, sir? I think it is very easy. Next one, for experimental verification, same model is coming for Charles 2 also. What is that experimental verification? Experimental verification means that is experimental verification, listen all of you carefully. That is Pt is equal to P naught plus P naught by 273 into T. Same formula. Vt is equal to V naught plus V naught by 273 plus T for Charles 1. For Charles 2 or Galois law, Pt is equal to P naught plus P naught by 273 into T. Okay. So for this one, very easy. For pressure and volume, if temperature is changed, this is about graph. Okay, this is V1, V2, V3, V4. This is Charles law 2. Now simple one for Boyle's law, V is proportional to 1 by P and PV is equal to constant means K, and for two gases P1 V1 is equal to P2 V2. These three are important for Boyle's law. Second one, Charles law, V is proportional to P. Okay, V by P is equal to K. So V1 by P1 is equal to V2 by P. Third one, P is proportional to T. So P by P is equal to K. P1 by T1 is equal to P2 by T. These are the main important formulas for Boyle's law, Charles law 1 and Galushat law. And see all the graphs. Okay, Nana? This today class is completed.